Common denominator on this one is 3m, so we're just going to multiply everything by 3m on this side and this side. So on the right side, it just turns into, these cancel out, so it's just 3 times m plus 4. On the left side, the first one, I'll write it out here, 3 times 1 over m, and then plus 3m times m minus 3 over 3m. So these cancel out here, and it's just left with 3m and 3m cancel out completely, so it's just left with m minus 3. Side over here, distribute, and the rest of it's just solving normally. Bring my m's to the left side. These 3's cancel out, so I'm just left with 12 over here, so m equals -6. On to the next one here. This one's pretty easy. The denominator is the same. Common denominator is 3x, so when I multiply the left side by 3x, it's going to be 3x times 4 over 3x, and then minus 3x times the 1. Think of it as a 1 over 1, if that helps. This is equal to x minus 4 over 3x times 3x. So these cancel out completely, and you're just left with 4 minus 3x, and these cancel completely, so it's x minus 4, so the rest of it's pretty simple here. -4 equals a -8 when you move things around. X equals 2. That's the easy part. All right, this one here, you need to factor first. So notice these are both exactly the same. So factor one, you factor the other one. This factor is to x minus 5x plus 2, or actually x plus 5, sorry. X plus 5 and x minus 2. X plus 5, x minus 2. That should have given me a hint right there. Equals 4 over x minus 2 plus 1 over x plus 5, x minus 2. So obviously our common denominator here is x plus 5, x minus 2. So if I multiply everything in this equation by that, each term times the x plus 5, x minus 2 on this side, and on the other side as well, x plus 5, x minus 2. On the left, everything cancels out, so it's just 6. On the right, the x minus 2 will cancel out from this one, and it's just going to be 4 left, but times the x plus 5 was left over. Everything is going to cancel here when I distribute that, so it's just plus 1. The rest of this is pretty straightforward solution. That's going to be 21, so I subtract it, it gets me -15 equals 4x, and that gives me -15 fourths equals x. Okay, this one here, you could have gone a couple different ways with this. If you really wanted to, you could have moved this over to this side and subtracted it, because they had the same denominator. It just been 1 over 5r squared minus 11r minus 12. Let's say you didn't do that and you decided to factor this first. On the bottom here, this would be 5r times something over here. So 5r, it's got to be an r. I got to subtract, and it's got to be a plus minus. And I need to make a -11. So let's see, if I do 2 and 12 on this, that'd end up being a little too big. Let's see here. Or 2 and 6, that's going to be 30. No, that's too big. So let's try something else here. How about we try 3 and 4? That'd be 20. If we do the other direction, though, I think that might work. 4 here and 3 here. So that would be 15 minus 4. Yep, so that'd work. So I want it to be a negative, so I want this to be negative plus, so that gets me a negative in the middle there. This might have been a hint too, in order to factor that. And of course, this should be the same on the other side. 5r plus 4, r minus 3, plus 2 over 5r plus 4. So I'm going to multiply everything by my common denominator, which is 5r plus 4 times r minus 3. So do that on both sides. I'm just going to write it as CD this time, because it's pretty obvious what it's going to be. On the left-hand side, it's going to completely cancel out. We'll just have 2. On the right-hand side, well, the common denominator is the 5r plus 4r minus 3, so that cancels out completely too. On this one, everything's going to cancel out except for the r minus 3 part of this. So that will cancel, but it would be plus 2 and then r minus 3. So the rest of it is simplifying. 2 equals 1 plus 2r minus 6. So that's 2 equals 2r minus 5. Bring that to the other side, and that's 7 equals 2r. So r is just equal to 7/2. All right, other problems here. We have this one, it's k squared, it's a k squared, it's a 2k squared. So what's the common denominator? 2k squared. Okay, so that's all I'm going to multiply everything by. So if I multiply this side by a 2k squared, it's just completely gone. I just end up with k squared minus 8k plus 16. I multiply this side by a 2k squared. The k squareds are going to cancel out in both of those and just be left with 2 on top. So it's going to be 2 times 3 minus 2 times k minus 1. So you got to remember that minus sign there. So simplifying here, 6 2k plus 2 equals k squared minus 8k plus 16. So I just need to bring everything to the one side, set it equal to 0. I'm going to bring everything to the right, since that's where my positive k squared is already. So this turns into a minus 6k, adding a 2k to both sides. And this is 8, so subtracting 8 from both sides makes this a plus 8. This is factorable. K minus 2, k minus 4. That makes 8 and adds up to that. So this is 2 and 4, my values for k, but I want to double check. Any of those going to be bad? No, both of those are acceptable, 2 and 4. This one here, same deal, just need to factor this. I'm going to guess, though, the factors are going to be m plus 3 and m plus 6 for this, just because good chance it's going to happen, right? And it turns out, yes, that is true. Kind of a good hint there. 4m plus 4, this is m plus 6, m plus 3, minus m plus 6 over m plus 3. So multiply both sides by our common denominator, m plus 6, m plus 3. And same thing on the other side here. M plus 6 times m plus 3. On the left side, the m plus 6 is canceled out, and I'm left with the m plus 3 times 5m minus 15. Okay. And on the right-hand side, well, everything cancels for this one, so it's just left with m squared plus 4m plus 4, and only the m plus 3 will cancel on this, so I'm just left with m plus 6 times m plus 6, but it's minus m plus 6, m plus 6 there. You got to be careful about that one. So yeah, you got to do a little bit of multiplication here. It's not that bad. This will be 5m squared, and in the middle, it actually ends up canceling out. This is 15m, and this is minus 15m. So poof, that's gone. You just got to do 3 times negative 15 here, which is minus 45, equals, this would be m squared plus 4m plus 4. Just keep that there. FOIL this out. It's all going to be negative because of this minus sign. So it's going to be minus m squared minus 12m minus 36 once you put all that together. See that these m squareds are going to cancel each other out here. So I'm not even going to worry about those. Simplifying everything else, I'll just leave the left-hand side for now. The right-hand side turns into a negative 8m, putting those together, and then a minus 32. So I bring everything over to the left side. My m squared is at. We get plus 8m here. And if I add a 32 to both sides, that's minus 13 equals 0 squared. So is this factorable? Let's check it out. It's got to be 5m and an m. We got a negative here, so it's got to be a plus minus thing. So factors of 8, or factors of 13, it's got to be 1 and 13. That's my only choice. So let's say we go 13 here and 1 here. 13m, 5m, yep, that subtracts to make 8. I want it to be a positive 13m and a minus 5m. So after solving those, you set each one of those equal to 0. You get m equal to negative 13 fifths and 1. And I believe both of those in this problem work out okay. Go back to the original. Yep, none of those would give us division by 0. All right, I'll just say one note about this one here. This is equal to 1. this right here, 25 minus 24, is also equal to 1. 1 minus 1, 0. So you could have simplified this problem right away by doing that, and then after that you got to combine these and set each one with the same denominator and divide and multiply, and it turns out on this one, I think the final answer was m equals -3. You actually got a 1 and a -1 with it, but both of those would have been extraneous, so you couldn't use it. I might show this in class, but